Welcome to my channel Fee Concepts CHM. This video is the first part of the series on Introduction to Lasers. Here in this video we will see about the interaction of light with matter, absorption, spontaneous emission, characteristics of spontaneous emission, stimulated emission, characteristics of stimulated emission. Lasers. Lasers comes under photonics, the field of photonics, where light is created using the photonic devices. Light is created, manipulated or detected. So there are various photonic devices like the LEDs, the solar cells, and lasers are one of them. So it is considered to be an outstanding invention of the 20th century. The full form of laser is an acronym for light amplification through stimulated emission of radiation. It is very different from the traditional light sources like the tube light and bulbs because of its characteristics like coherence and monochromaticity. The theory of laser was given by Einstein in 1916 when he had predicted about the process of stimulated emission. Lasers find many applications in different fields like communications, eye surgery, and weapon guidance in wars. We will see now the interaction of light with matter. When we talk about light, it is a radiation. So we suppose that the radiation is incident on the material. So this radiation can be viewed as a stream of photons. Photon is considered as a small packet of energy. Each photon carries an energy E is equal to h nu, where h is the Planck's constant and nu is the frequency of incident radiation. Now, in the diagram, we can see there are two energy levels of the atoms, one corresponding to E1 and the another corresponding to E2. The difference between the two energy levels, E2 minus E1, will be equal to h nu. Now, suppose we incident the radiations, we incident the photons onto the material. When they travel through the medium, three different processes can occur. One is absorption, second is spontaneous emission, and third is stimulated emission. In any of these cases, if you will see, a light may be absorbed or emitted by the atoms during the transition from one energy state to another. So the atoms can go from one lower state to higher state by absorbing or emitting the photons. Now we will see the first process, that is absorption. Suppose we will assume that the atom is in the lower energy level E1 and we incident a radiation having energy h nu, and this will be equal to the energy difference between the two energy levels, that is equal to E2 minus E1, or we can write it down as delta E. So this radiation of this much energy is incident on the photon. The atom will absorb this photon H here is the Planck's constant and nu is the frequency of the incident radiation. After absorbing the photon, the atom jumps to the higher excited state, that is the having energy E2. So this process is called as absorption. So in this process, the incident photon is lost. Next is spontaneous emission. Suppose the atom is at the lower energy level and it is excited to the higher energy level. That is something which we had seen in the absorption process. By absorbing a photon, the atom is excited to the higher energy level represented by this level E2. Now here the atom cannot stay in this excited state for a relatively longer time. So within a time of about 10 raised to minus 8 seconds, the excited atom de-excites to the lower energy state E1. And during this process, it will release a photon having the same energy h nu, which is equal to E2 minus E1. So spontaneous emission is a process by which an excited atom returns to the ground state very soon. The frequency of the emitted radiation is directly proportional to the energy difference between these two levels. So nu is proportional to E2 minus E1. Now we know that nu is inversely proportional to the wavelength of light lambda. So we can also say that 1 by lambda is proportional to E2 minus E1. So smaller the energy difference, greater will be the wavelength emitted, because the relation is inverse. Characteristics of spontaneous emission. So now here no external triggering is required. We don't incident any radiation from the outside. It is random in character. Like in a group of excited atoms, each atom can spontaneously emit a photon, and these emissions, they are all going in random directions and in random phase. The light that is produced in this process is not monochromatic. They will be of different wavelength. As different atoms in the source emit photons in different directions, in random directions, hence the light spreads in all the directions around the source. This again, the light that is produced, it is incoherent, it is not in the same phase. Spontaneous emission, we can observe this in the conventional light sources like the ordinary light bulbs. And this process is opposite to that of absorption. In absorption, we incident a photon which is absorbed by the atom, and in the spontaneous emission process, the atom emits a photon. Stimulated emission. This concept was given by Einstein. It is a kind of force emission. So we'll see what it is. Now in this figure again, you can see that an atom is there in the excited state represented by E2. We will incident a photon of frequency nu, which will be equal to the E2 minus E1 upon H. Now when this photon is incident, a collision will take place between the excited atom and the incident photon, and the atom will be forced to drop into the lower energy state E1. During that time, a photon of the same frequency nu is emitted. So we had seen like for one photon, when we incident one photon, we get two photons. So with an incident triggering photon, one more photon is also produced. If these two photons further trigger other excited atoms, then we will get identical multiple photons. Like one photon, when you incident, you get two photons. Two photons will then stimulate the other atoms, other excited atoms. So this two will become four photons. Four photons will we will get eight photons. Hence, the incident photon gets coherently amplified in this process. Same, all these photons are having the same frequency, same energy of h nu. So we say that what occurs is the amplification of the light by stimulated emission of radiation. Characteristics of stimulated emission. So from this diagram we can understand that the constructive interference of all the waves in the same phase causes the light amplification. The net intensity of the light will be directly proportional to the square of the number of atoms radiating the light. We'll just summarize whatever we had seen. We had seen first the process of absorption. Next, we had seen the process of spontaneous emission. And third, we had seen the process of stimulated emission. Thank you for watching this video.